Hey everyone, it's Dakota Wixom here from quantbros.com, and today we're going to cover calculating value at risk and conditional value at risk, otherwise known as VAR and CVaR, in R. We're going to make this super fast. There's a lot of packages we can use to help us out. Let's get right to it. So to kick things off, first we're going to load in a library called QuantMod. This is very useful. If you don't have it installed already, hopefully you know how to install packages, right? And if you don't, go watch our bootcamp part 1 tutorial in R, and we'll get you right up to speed. For everybody else that can follow along, let's go for it. So we're going to load in QuantMod. We're also going to load in my personal favorite, Performance Analytics. Go ahead and run those lines. Alright, so first thing we've got to do is download a time series to work with. So let's just pick a stock. Let's go with Microsoft.prices, because we're going to download prices for calculating value at risk. Hopefully you saw our value at risk tutorial. If not, I'm going to link it here. And really all we're going to do first is get symbols. Microsoft auto.assign equals false. So that's going to assign this to this variable. So now I've got Microsoft prices, but really all we need is the adjusted close. So let's do AD. That's also from QuantMod. Now we've got all the adjusted close prices of Microsoft. Let's say I only really want to go back to 2000 just to make this easier. So let's do max date equals, and we'll go in year dash month dash day. That's January 1st, 2000. And then we're just going to add into the get symbols in the first parentheses there. From equals max date. All right, so that's as far back as it's going to go is 2000. And you can see that here. And it goes up until today, the very snowy day of January 11th, 2017. And now we're going to calculate returns. So we'll just go Microsoft.rets equals daily return. You can see that's from QuantMod as well. Isn't that handy? We're going to paste in our Microsoft prices there. And boom, we've got our daily returns for Microsoft. Isn't that nice? Now that we've got our returns, we can calculate value at risk, just like we did in Excel, if you saw that tutorial. Paste in Microsoft returns there. Let's go with the 95th percentile for value at risk, and we'll make the method historical. And if we run this line there, you can see 95% VAR for Microsoft is 2.87%, and negative, of course, because it's a loss. Once again, if you need more information on this, we really go into detail in the Excel tutorial. We can calculate the 99th percentile just by changing this p-value, and there you go. Of course, it's higher. We know how that works. Now, if we're curious about how the function works, you can do question mark VAR, the name of our function. So we can also calculate conditional value at risk very easily. We'll CVaR, Microsoft rets, and again we're going to pass in a p-value. Let's go with 0.99. Method equals historical. We'll cover the other types of calculations later. And you can see our CVaR there, or otherwise known as expected shortfall, is higher than our VAR, which is expected. That's exactly what's supposed to happen. And I mean, there you go. What is that? That's 5 lines, and we've got VAR calculated at 2 different intervals and CVaR, 2 different alpha levels and CVaR. Pretty amazing. That's the power of R. So let's take this a step further. Let's make a vector of stocks that we might be interested in calculating value at risk for. So let's go with Microsoft, Apple, Amazon. Now let's say we've got a portfolio, so we need to give these weights. Let's go with a, let's say a 50% weight in Microsoft, 10% weight in Apple, and a 40% weight in Amazon. Of course, they should sum to 1. And then let's just do get symbols of our tickers, right? And then remember our max date. So let's just go ahead and pass that in there. Oh, did I not run tickers? Yep, there we go. Now this is going to take a few seconds because it's downloading data for each of the stocks. But once we've got that, yep, and you can see it returned there. And we didn't do auto.assign equals false because that doesn't work for multiple stocks. Don't worry about that. But let's create an object now called portfolio or port.prices. Let's merge all of these prices together and make sure we get the adjusted close from each of these. So let's do the adjusted close of Microsoft, the adjusted close of Apple, the adjusted close of Amazon, and there we are, port prices. Check it out. And just in case, we can do na.omit to make sure we've got no days that are, that are missing data. Okay. Now let's calculate returns for each of the stocks, just like before. Let's go port.returns. But maybe we'll use a different function. In fact, this is better because we're doing it on multiple stocks at once. So we'll use the ROC, which is from the TTR library, which should be loaded in with Performance Analytics. It might even be loaded in with QuantMod as a required package. You can use this to calculate returns. All returns are is a rate of change, right? ROC, rate of change. And we'll just pass in the object here, the portfolio prices. And we'll just make sure that we've got discrete returns, right? We don't want them continuous. And go ahead and run that line. Now if we take a look at our object, boom, we've got returns for everything. We don't want that first NA, right? So let's get rid of that, -1. And head again. Boom. Good to go. Okay, so now we've got the returns for each of our stocks. But see, they say Apple.adjusted, Amazon.adjusted. I don't really want that there. I just want it to look nice. So I'll just rename the columns there with our tickers. And we should be good to go. All right, so now let's calculate value at risk for our portfolio of returns, right? And let's look at the 99th percent confidence level. Let's pass in our weights there, which is, of course, weights. Let's go with the portfolio method, which is really important component, right? So this will look at each stock's contribution to the risk of our portfolio rather than just the risk of a single stock. And let's go with a different method this time. Let's go with Gaussian, right? We could also go with modified if we wish. In fact, yeah, let's do that. Let's go with modified because the returns are most likely skewed. It's going to be a much better estimation of tail risk, right? So this is actually Cornish-Fisher Var. You could read about it in the documentation of the function. It's in there. Cornish-Fisher Var. So let's run that line. And you can see this is actually the value at risk of our entire portfolio there, given our weights at the 99th percent confidence level. You can look at the contribution of risk for each of these stocks. So you can see Microsoft is adding to this number, right? 2.5% of the risk of our portfolio, right? Or 2.5% value at risk. Apple 0.379 value at risk. Amazon 4.24% value at risk. So this is saying our weight in Amazon is giving us a 4.24% potential loss in the worst 1% of scenarios. Meanwhile, with the same portfolio weights, Microsoft is only going to give us a 2.5% loss in that worst 1% of scenarios. Now, the contribution can be measured as a percentage, right? So Microsoft's contribution to the risk of our portfolio is about 35%. This is less than the weight, right? So we've got 50% of the weight of our portfolio in Microsoft, and it's only contributing 35% to the VAR at the 99th% confidence level, which actually means that it's a less risky stock than the other stocks in our portfolio. Apple, on the other hand, Amazon, on the other hand, contributes 59% of all value at risk for our portfolio at the 99th% confidence level, but we only have got a 40% weight in the stock. So it's overweighted in risk. So you could ask the portfolio manager, is that really what you want? Now, Amazon is a growth stock, so that's to be expected. Microsoft, on the other hand, really isn't, so that's of no surprise there. If we want to do this with CVaR, you can see I just copied that line, add a C. Now we've got CVaR. It also works if you do ES for expected shortfall, same thing, or ETL for expected tail loss, same thing, once again. And remember our VAR level, what was our VAR for our portfolio? 7%, right? Our expected tail loss, our maximum expected shortfall is 7.79%, which is higher, and of course we expect that to be higher. The contribution to this number, it works the same as in value at risk here, right? The numbers are going to be different because your CVaR number is different. In this case, in the worst scenarios on average, look at Amazon's contribution, right? That's much higher. That's 75%. I think before it was 59, right? So it's really important to look at different measures of risk. There's all sorts of other measures of risk and ways to calculate VAR and CVaR. You can do Monte Carlo methods, but we're just going to roll with this for now, okay? All right, so what if we wanted to compare the different methods of calculating value at risk for each of the stocks? We're not looking at portfolios anymore. So let's just go with VAR historical first. So VAR, let's pass in port returns again. Do P equals 0.95. Let's go with 95 this time. Weights equals null. And now if we do portfolio method equals single, it's going to ignore the weights, right? That's why we have weights equals null. And all we really need to worry about is that individual stock, each individual stock, and we're going to make it historical. And let's just run this line here. And you can see the value at risk for each of those stocks, right? The historical value at risk. Now, what if we wanted to check out the Gaussian and the modified? So let's just paste 2 extra lines here. Call one Gauss, the other one mod. Now, if we run these, we got to change the method, of course, right? Gaussian, modified. Run this line, run the other line. Check out Gaussian. Awesome. So this is higher than historical VAR, it looks like. And modified duration, modified VAR is lower, right? Interesting. Okay, so let's put these all into a single data frame, right? Why not? And then maybe we can add portfolio VAR to compare them all. So let's do all.var equals data.frame. And we'll just R-bind everything together here. Let's go with var hist first, and then var Gauss, and then var mod. And it's going to give me a warning there because they've got the same row name. It's going to say VAR for each of them, right? Which is annoying. So it just got rid of the row name. So we'll just rename it here, just to be clear. It's no problem. This will just help us remember, right? Because if you look at this, you don't know which one's historical, Gaussian, or whatever. So we'll just rename the row names. Now if we check out the object, there we go. We've got them all in a line here. And now let's calculate portfolio var. So let's go with port var dot hist, let's call it, and then we'll just grab this line here, copy it, paste it. Now make sure we change our weights to weights equals weights. Oops. Weights equals weights. Our portfolio method, of course, needs to be component, right? We've got our method is historical. Run that line. Check it out. Good to go. Now let's do another line for Gaussian and modified. So let's go with Gauss, mod, Gaussian, modified. Run this line, check out Gaussian, and you can see, of course, it's spitting out the whole shebang here. All we really want is the portfolio var, so let's just extract that. So $var. Now I know this is an array, so we're also going to have to do 1, 1 there to make sure that we get only the number. And if we check out modified, I think it's the same story. Yep. So we need $mvar, right? MVAR 1, 1. Run that. Modified. There we go. And we'll just throw them into a data frame together. Actually, why don't we just take our all.var object, right? Remember that? Let's create a new column. We'll call this $portfolio. We'll just set it equal to 0 for now, so you can see we're creating a new column. Then we're going to fill that out. So let me just copy this and paste this in here so you know that it's a part of it. And now we do all.var $portfolio is equal to the vector with historical var, and then of course Gaussian var and modified var. So we just replaced this this column with our numbers. And now we can compare everything, which is great. And actually you can see portfolio var is a positive number, and the individual var for each of those stocks is a negative number. That's actually an oversight. They should all be negative or all positive, right? It means the same thing. They're all losses. But just to make it clear, we'll just say all.var is equal to the absolute value of all.var, right? Now everything's on the same scale, right? Everything's positive, so that's fine. And of course we know that they're a loss. If we wanted, we could do the negative abs, right? If we really wanted to, now we can make them all negative, but I'll just keep it positive. That's kind of an academic debate. Should it be negative? Should it be positive? It really doesn't matter, but some people really care about it. Now let's add another column. We'll do type, right? And you know how this goes, so we'll just give it a vector, hist, gauss, and mod. Now I'm doing this because we're going to plot it using ggplot. I'll explain in a second. Yep, so we've got now another column saying, hey, this is a historical row, this is a Gaussian row, this is a modified expected short or a modified row, and it also says this in our row names, but a lot of functions don't recognize row names. So let's do library reshape2, and of course if you don't have this yet, install it first, then run library. We're also going to do library ggplot2. Also install that if you don't have it. And then we're going to make an object called plot var. And what we're going to do is melt this object. So let me just run this line here so you can see what's happening. it's turning this kind of into fewer dimensions, so it's easier to plot for ggplot and also for other uses. So it's kind of called, I think it's called flattening your data. It's also useful for SQL tables and things like that. We'll just make this clear. We'll do variable dot name equals ticker and value dot name equals VAR, value at risk. Plot var is just going to yell at me here because I'm not really doing this the way that it wants me to, but that's okay. It looks nice for me. So we've got the type, the ticker, and the value at risk, and you can see everything is its own row with each of the variables, right, is a column. And this allows us to plot much easier using ggplot. So we'll just pass in this plot var melted object. Now don't worry about this. We could do a tutorial on ggplot later, but just know that I'm accessing the type column here by saying x equals type. I want this to be the x dimension of my graph. For y, I want the value at risk, right? Of course, VAR. Now for the color of the bars, I want it to be based on the ticker, right? Now we're going to add, this is kind of strange syntax here if you've never used ggplot, but I'll walk you through it here. And then we're going to, because of course we're making a bar graph, stat equals identity. And then we're also going to do position equals dodge. And before I run this line, I'm going to have to expand my window here because I know it's going to be difficult to see. And run this line. And you can see we've got our, let me bring this up here. Hopefully you can see this better. So ggplot produces some great graphs. It's very famous in the R community. You can see we've colored this based on the asset. We've also got purple here for our entire portfolio. We're looking at the var of each of these objects. So Microsoft var pretty low across the board. Apple in the middle. And actually for modified, Apple's pretty high there. Amazon, on the other hand, look at that. For Gaussian and for historical. And our portfolio var is lower than most of the other stocks, which is very common. It's just because of the way that covariance works with the value at risk and conditional value at risk calculations. Portfolio var and CVaR tends to be lower than most of your positions. There is a mathematical definition. And Gaussian overall tends to produce the higher value at risk estimates for us, historical in the middle, and modified lower. So depending on how risk averse you are, depending on what type of returns you're using, depending on what confidence level you're using, you might be using a different measure for value at risk, and that's completely up to you. We could run this entire thing with CVaR, right? I'm not going to do that because it's going to take a little while. It's going to be a repeat for you guys, but all you need to do is change the calculation up here to CVaR for each of these. Pass it in. You'll probably want to change a few variable names and labels to make it clearer. But we can compare now the value at risk for each of our stocks and our portfolio. That's all I've got for you today. We can go more into ggplot2 if you're interested. Talk more about melting, different types of plots. It's a very powerful package. But today I just really wanted to show you value at risk calculations in QuantMod, how useful this package is, and performance analytics as well. We can use it for all sorts of other things. We can do this on a rolling basis, right? Which is very popular. We can turn this into a strategy based on value at risk projections. We can estimate or we can calculate value at risk on a rolling basis and see where that level is breached, right? Where maybe where some really bad events were unexpected, unforeseen by the models, and we could say, hey, how bad were these scenarios? That's all things to explore in a future tutorial, but I hope you enjoyed it, and this is Dakota Wixom signing off once again from quantbros.com.